So the DC circuit response. Okay, so we have here your I of t. Okay, and let's try to graph. No, first let's look at a time is equal to 0. Given this expression here in the bottom, so what will be a time is equal to 0? Okay, so let's try to plot it. Okay, so you can see that in the given expression or behavior, so you have e to the 0 is actually 1, so therefore your I of 0 is equal to 0, and in which case in our assumption that's correct, no? So at time initial condition, that's actually 0. Okay, because the switch is on at time is equal to 0, meaning beforehand it is 0. Okay, or just before or during the switch, okay, it is 0. Okay, and then at time is equal to infinity, although we cannot reach that number. Okay, so we try to see what will be the value of your I of infinity. Okay, so e to the infinity here is equal to 0, therefore you have your I of infinity equals Vs over R, meaning in your graph you have this, you have that expression. Okay, so therefore your I of t, if you want to plot at respectively between 0 and infinity, you have this graph. Okay, so that's we call the exponential behavior of your RL circuit, meaning it doesn't go this way, no? So your circuit at the moment it is on at time is equal to 0, it doesn't go immediately at Vs over R. Okay, so it doesn't go like this. Okay, so that's the importance, or that's the impact of your inductor. Okay, because of your inductor, it delays the current. So we know that this is current, so the inductor actually delays your current. Okay, so in reality there's no such thing as this, no? So the one I'm drawing now, so there's no such thing in reality, so therefore there's always a curve. Okay, there's always a curve, so it doesn't change immediately to that thing. Okay, so that's very important. And if you look at the equation, okay, so actually you can change the curve, you can change the how it is curve. Is it really goes higher or maybe slower? Okay, so we have this time constant here. Okay, tau is equal to L over R. The ratio between the inductance and the resistance makes your curve, uh, you define the curve. Okay, so by changing the ratio of L and R. Okay, if you have lesser L, it might be closer to, okay, like this one, this might be lower L, okay, from the previous curve. Okay, so it depends on your L and R. So it is impossible in this case now, if you can look at this, it's impossible to get R equal to 0 because it will go to infinity. Okay, so that's why in reality there's no zero resistance. Okay, because that would mean if this is 0, then you will have this case. If your R is 0, then you have this case. Okay, and take note also that Vs over R is only achievable at times equal to infinity, and there's no such thing as infinity in reality, but we can have a very huge number, but your current only approaches Vs over R and it cannot reach that point. It can be, for example, if your Vs over R is 10 amps, okay, because this is in the unit amps, this is current. Okay, so your value here, let's say this is in 1 million time. Okay, so therefore here it is close to 10, like 9.9999. Okay, but it doesn't reach 10. Okay, so that's very important. Okay, that's it. That's the DC circuit response of your RL circuit.